Good morning everyone. Let me know if you can hear me loud and clear. Let me know if you can see me. This is Shreyas here, your physics master teacher, going live on a Sunday morning just because the 2021 aspirants have an exam in the next 2 days. Hello my lovely, amazing warriors. Hello Bhavya, Dhanashri, Om, Samuel, the unknown, Venkatasai, Sumant, Sanspriya. Hello Krishna, welcome everyone. Hi Alini, hi Manzoor. कैसे हो सब लोग? Good morning. Hello everyone. Hi Aditya. Hello Sanjal. Hello Anushka. Hi Hasani. Nice to see all of you. So guys, I am Shreyas. I am the HOD of physics for JEE division, and I'm also teaching physics on the Enthuse channel. And I am here on a Sunday morning just so that you guys can revise as many formulas as possible today. And it's not just revision. Let me tell you, today we are also going to see the link between different chapters. We are also going to see how to remember these formulas in a much easier way. We are not going to do chapter wise formulas. That's the best part of today's class. Today you are going to see the link between all the chapters, and you will see how you can remember and compare the different chapters, and you will be able to remember these formulas in a much quicker way. You will see that by just applying some techniques for one particular chapter, or if you memorize the formulas for one chapter, you automatically memorize the formulas for other chapters as well. Nice to see all of you. Thank you for all the love. Sandeep from Andhra Pradesh. Thank you for all the love from Maharashtra. Thank you for all the love from throughout the country. Yes, Naveen, we are going to cover almost all the formulas. Yep. Nice to see all of you. So, if you want to know more about me, you can definitely follow me on my Instagram handle, which is Shreyas_Vedantu, where I keep posting up my regular updates. And let me tell you, tomorrow is going to be a very important session, and that's Sure Shot 60. Last time when we conducted this Sure Shot 60 session, so many questions came directly from this session, and also some of the questions are very similar to this. Not just that, even the mock test which we conducted, there were so many questions from the mock test. So if you have missed the mock test, please watch it. It was conducted yesterday. It's there in our past videos. Many questions were getting repeated in a similar manner. Now, today I'm going to do the physics formula revision. Tonight, Shimon sir will be also revising the formulas for maths. And then tomorrow is the, Monday 1:30 p.m. is the Sure Shot 60. Okay. So, before we go ahead, let me also tell you one more thing. If you want to be one of these toppers, so that next year when the 12th standard batch will be passing out in 2022, you want your photos to be seen out here, and you want to, not just for the photos guys, I mean you want to get into the best of the colleges. I mean, look at these results out there. These are all Vedantu students. 99.97 percentile, 96 percentile, 99.91 percentile, and not just that, forget the toppers, even the average student is performing better than a normal student, be it boards, be it JEE Advanced, or be it mains. In fact, the interesting thing is 1 out of 2 Vedantu students have already qualified for JEE Advanced, and it's all because of the amazing teachers, it's all because of the amazing content, it's all because of the mock tests that we give, it's all because of the strategies that we give. So, if you are interested to crack the upcoming 3rd or the 4th attempt, there is a crash course running, not for 10,000 but for 4,000 rupees when you use the discount coupon code SHCC. Check out all the details which is there in the description box below, because all the topics will be covered in this particular crash course. And I feel that you must join it, because you are also going to get the test series with discussions along with doubt solving, and these batches are in English. Yeah, these batches are in English, so that's a very good thing for all of you. So let's start. Let's start with our revision of formulas today. So let's see what we can do first. Somebody is asking, can we watch this for NEET? Yes, bacha, this lecture is also useful for NEET. Definitely you can watch it for NEET. No problems, you can watch it because the syllabus is same. There might be few formulas which might be a little bit more here and there for JEE, but 90% to 95% will be similar. Okay, so let's get going. Electro, or let's say gravity. So I'll put gravity over here, then I'll put electrostatics, or in general electrostatics and electrodynamics part of physics, and then the magnetism part of the physics. Now, there is a very nice similarity between all of them. Just to begin with, you can see the close resemblance between these three topics starts right from force. Like the force of gravity is G m1 m2 divided by r square for gravity, whereas in electrostatics it is 1 upon 4 pi epsilon naught q1 q2 divided by r square. And in magnetism, understand that same force will be mu naught by 4 pi. Instead of charges, you have magnetic poles. This is m1 m2 by r square. Please understand these are poles here, and this m1 m2 is mass over here. So that's the difference. Be careful. Yep. So this formula session will last for quite some time, obviously between 1 to 2 hours, somewhere between that. And everybody knows this value. It is 9 into 10 to the power 9 in SI units, and this is 10 to the power minus 7. Now, not just this, guys. In fact, even in field, if you calculate the electric field or gravitational field or magnetic field, you will see for gravitation the formula is Gm divided by, okay, Gm divided by r square with a r hat and with a negative sign. What this tells you is that if you have a mass and if you are at a distance r, the gravitational field is towards the mass. That's why the negative symbol. This is a unit vector. This does not have any magnitude. The magnitude is 1. The magnitude is over here. This is only the direction. Like you write 5 I cap, 7 I cap and all of that. Similarly, in electrostatics, the formula is 1 upon 4 pi epsilon naught q divided by r square, and this is r hat. So this is with the bar. So again, you have a charge. You are at some distance r. So the field over there is in the direction of r hat. Similarly, next formula for magnetism, if you have a small element dl which is carrying current I and you are at a distance r, then the magnetic field is given by mu naught by 4 pi I dl cross r hat. Okay, dl bar cross r hat, and you have r square over here. You can see the close resemblance again between all the formulas. You have a constant. Instead of charge or mass, over here you have ideal, and instead of just r hat you have cross r hat, and in the denominator you always have r square. Yes. So let me be very clear about this. This is also for JEE and NEET. Number 2, this is not chapter wise, Prabhnur. We are relating all the chapters together. Okay, it's not like this is only gravity, electro and magnetism, all the chapters combined together. Now the next important thing that you can see between these three chapters is related to, you know, the different geometries. So let's say again, let me put electro over here. Oh sorry, I wanted to put gravity, we had electro, and here we had magnetism. Now if you talk about the geometries, the first geometry being the shell, if you have a shell of mass m and you are inside the shell, the field is 0, whereas when you're outside at a distance r, the field is Gm by r square. I hope you remember this. What is E? E is the field, bacha. Electric field, gravitational field. Please don't tell me, guys, you do not know anything about field or anything, because if you do not know anything, then this lecture will not be useful. Remember, this is a formula revision session plus trick session. Okay, so you cannot say that sir, what is this E, sir, what is G? I mean, if you are not knowing that, then it will be a big problem. Let me tell you that. Is shell a solid? No, shell means it's hollow. Always shell means hollow. Solid sphere or sphere usually means solid, completely full inside. Similarly, in electrostatics, again when you are given a shell, all right, and if you are inside, the field is again 0, but the moment you go outside at a distance r, the formula for field is kq by r square. So this is the field inside and outside. In magnetism, you do not study shells. Okay. When you talk about solid spheres, okay, so it's completely full inside, okay. Then when you are inside the solid sphere at some distance r, the field value is given by gm small r divided by r cube. That's the value inside. And when you are outside, the value of the field, let's say you are somewhere here, the value of the field here is just gm by r square. Now the point to be noted is that when you are outside, the shell or solid sphere behaves like a point mass, as if it's a point mass and you are at a distance r. But when you are inside, things change. Remember, whenever you are inside a shell, the field is 0. But whenever you are inside a solid sphere, there are some shells which are inside of you and there are some shells which are outside of you. So for those shells which are outside of you, the field produced by them would be 0, or their contribution will be 0 for those shells which are outside of you. Only those shells which are inside will contribute. Yes, I hope this is clear. Yes. Now, next thing over here in electrostatics, you will see that again, if you have a uniform charged sphere, okay, if you have a uniform charged sphere, what you will get is very similar, guys. Again, when you are inside somewhere at a distance r, the value of the field will be k q r divided by r cube. But when you are outside of it, then the formula will be k q divided by r square. For magnetism, there is nothing like that. There is no solid charged magnet. No, we do not have that. Good morning, everyone. Yes. Now, oh guys, no, the PDF will not be there. You have to write it down or you take screenshots. So as and when I'm explaining, please scribble it down in your notebook. That's the best way. Or if you feel that, no, I do not have so much time, it's okay. You can watch this. You can take screenshots whenever possible. That's also okay. All right. Now, the next thing that you should know is for a ring. Let's go to the next geometry, guys. Let's go to the next geometry. Okay, so the next geometry that we are going is for a ring. So if you have a ring of mass m and some radius r, and if I'm standing here, then the value of the field is given by, I don't know if you remember this, but it is gmx divided by r square plus x square whole raised to 3 by 2. This is x, this is r, the radius, and this is x. So the field changes. In fact, if you put the value of x as 0, you will see that the field will also be 0, because at the center all the fields will cancel out each other. Similarly, for a ring which is charged with charge q and the radius is r and you are at a distance x, the value of the field will be again given by k q x divided by r square plus x square whole raised to 3 by 2. That's what you're going to get. Yes. Next up, for magnetism, you also have a ring, but instead of a ring, you call it as a coil. You usually call it as a coil carrying current. This is R, and you're on the axis of the coil. The magnetic field is given by mu naught I, R, and you have 2 over here, R square plus X square over here raised to 3 by 2. To satisfy the powers, I'll put R square. Why did I decide to put R square? Remember, whenever you write the formula for magnetic field, in the denominator, the power of length is 1. The dimension of length is 1 in the denominator. So, R square raised to 3 by 2 will become cube in length. lengthwise, dimension wise, it will become cube. So to cancel it out, that's how I remember that there should be a square on the top, not r. So that's how you can solve this. Remember, this formula can also be used when you are at the center of the coil, because when you put x is 0, just put x is equal to 0, this will go out, r square raised to 3 by 2 will become r cube. R square by r cube will become r. So you will just get at the center, okay, at the center, magnetic field at the center, the standard formula, which is mu naught I by 2r. Okay, so that's what you will get. Now, you also have linearly charged wires. So if you have a wire which has lambda charge density and you are at a distance r, then the field produced at any point is given by 1 upon 4 pi epsilon naught lambda by r. Now the best part over here is you can use this formula, whatever I am going to write, for any wire which is charged, be it of any length. This is alpha and this is beta. So what you get over here is sine alpha plus sine beta. So that's the field that you get along the x-axis. Very, very important formula. You do not have the geometry in gravitation. In case of magnetism, when you have a charged, actually you will not have a charged wire, but you will have a current carrying wire and you are at a distance r, then the magnetic field is given by mu naught by 4 pi I by r, and again the same thing, sine alpha plus sine beta. That's what you will get. You can see the formulas are very, very similar. Do you see the resemblance? Yes, do you see the resemblance? Captain Cool, screen is visible. I am guessing that your resolution is less. Your resolution is less. Yeah, please check it out. Okay, please check it out. Just check the settings and check your internet connection. I'm pretty sure it will be fine once you do that. All right, good morning everyone. Good morning everyone. I hope everything is fine till here. Next formula that you should know, which is not there in gravity but it is there in electro and magnetism. If you have a charged sheet, then the field because of it, which will come both ways, will be given by sigma by 2 epsilon naught. What is sigma? It is coulomb per meter square, charge per area. Remember, this lambda was coulomb per meter. Okay, this was linear charge density, this is areal charge density. So a charge sheet produces electric field both ways. A similar thing is there in magnetism also. A similar thing is also there in magnetism. So what you have is a sheet which carries current. A sheet which carries current. And there is linear current density given, then the magnetic field is given by a very similar formula. Instead of sigma, you have lambda, and instead of epsilon, you have mu naught and divided by 2. What is this lambda? Understand? This lambda is nothing but ampere per meter in this case. It's the linear current density. This is a sheet carrying current. So how much current is there per unit meter? That is the formula. Mu naught into lambda. You can see whenever epsilon comes below, mu naught goes on the top. Whenever sigma is there, per unit area is there. In magnetism, it becomes per meter. That's how it works. That's how it works. Kamesh, no bacha, the PDF won't be available. You have to make notes. Okay, cool. So, well, I hope everybody is clear till this point. Yes, Jupudi, entire physics only will be done in this complete session. Everybody fine till this point? Shall we go ahead? I hope everybody is clear till this point. Shall we go ahead? Let me know if you can see me. Let me know if I'm audible. Let me know if you can hear me loud and clear. Let me know if you can see everything on the board. Okay. Cool. Very good. Very good. Thank you, Jaya, Swati, Hasini, Chaitanya, Mayana, Shasha, Jaya, Kela, Ram, Dora, Sandeep. Yes. Why r square? Because that's the formula, man. and it should also satisfy dimensionally, that's why. Okay, let's get going to the next one. Okay, let's get going. Okay, cool. Now, the next one that I want to talk about is the field. In case of gravity, when you have a mass, the field is always attractive. That's how the field is. It always ends on the mass. But in electrostatics, the field can originate from the positive charge and it can also terminate, but on a negative charge. In case of magnetism, there is no termination or start. It is always in the form of closed loops. They do not intersect, they do not have a start or end. Okay, that's how it works. Next important thing that you should know is that in all the three scenarios, in all of them, always remember any field will always go from high potential, high voltage to low voltage. That's the standard direction of the field. It always goes from higher voltage to lower voltage, higher potential to lower potential, be it gravitational, be it magnetic, be it electrostatic, all kinds of potentials and fields follow the same rule. And also remember, wherever the density is more, so the strength of the field, is directly proportional to the density of the field lines. The density of the field lines. It's directly proportional to that. Okay, very, very important. Next up is only for these two cases, and it is for electrostatics. There is some formula called as energy density. So the formula for energy density is half epsilon naught E square. E is the field. Every field stores energy. The density of energy means joules per meter cube. So how many joules of energy is stored in the field? That is, energy density is given by half epsilon naught E square in case of electrostatics. For gravity you don't have that. But for magnetism, the magnetic field energy density is very similar. Instead of epsilon naught, you put mu naught, but below. And instead of electric field, you put magnetic field. So that's the formula, guys. So density is half B square by mu naught. Okay, so remember these formulas, very, very, very important. Yep. Yes, this session, I don't know how much long will it go, but I have not planned what's the end time, but just guys focus on the session. Do not get deviated. This is really serious. I mean, come on, we are revising all the formulas of physics out here. Thank you, Ritesh. Thank you, Akhil. Yep. Yeah, today there are no questions. It's only formula revision and seeing how the formulas are related. Nobody in your school or coaching would have done this, comparing all the formulas together for all the chapters. Lot of you revise the formulas in the wrong manner. What you do is, sir, vectors formula, a square plus b square plus 2ab cos theta, kinematics formula, okay, Newton's laws formula. That is not the correct way of revision. You have to see the relationship between chapters, guys. If you are doing that before then, probably you are doing it wrong. Okay. Now, once you are done with this, let's go ahead. Okay. Now, slowly moving on to resistance, and then capacitance and inductance. Okay. Now, starting with what's the formula for resistance? The formula for resistance for a wire of certain area and certain length is given by rho L divided by A. For capacitance, there are three formulas. For a parallel plate capacitor, it is epsilon naught A divided by D. For a cylindrical, capacitor, it is 2 pi epsilon naught height of that cylinder divided by log of B by A. And for spherical capacitors, okay, so this is spherical capacitor, shell inside a shell, the formula is 4 pi epsilon naught 1 by R1 minus 1 by R2. So these are the standard formulas which you should know, guys. Next up is Shashank, don't spam, don't worry about null point, this point, just focus on what is happening right now. Okay, and Vinay, you're not going to get the PDF, bacha, sorry, you have to write it down. Lot of teachers do this. I really don't like teachers giving, all the handwritten notes out there just so that you can revise. Guys, it's not the correct way. You have to make notes by yourself. Understand, by watching somebody cycle or watching or downloading a video of somebody's cycle, you do not learn cycling. You learn to ride a cycle when you actually sit on a cycle and go through it. So understand, I do not give notes that way. So you have to make sure you scribble when you see this. Yeah, especially for physics. For other subjects, maybe it might work, but for physics, definitely it will not work. Remember that. For inductance, self-inductance formula. Everybody should know the self-inductance formula, guys. Okay, so what's the self-inductance formula? Mu naught pi r square, n square and L. So mu naught is permeability, pi is pi, r is the radius, okay, n is the number of turns per unit length of that solenoid. This is the L of the solenoid, the self-inductance of the solenoid. But you also have the formula for mutual inductance of a solenoid, one solenoid inside other solenoid. So the mutual inductance for solenoids is similar formula, mu naught pi r square, but instead of n square you have n1 n2 L. What is this L? L is the length of the solenoid. Okay, this L is the length. Okay, this is the length. This n is number of turns per unit length. Why do I have 2 n1 n2? Because one is inner solenoid, one is outer solenoid. That's why you will get it. Understand that. Yeah. Next up that you should know. Okay, so here there are some special formulas for resistance and current and all of that. Like current is NVIDIA, that graphics card company, NVIDIA. So current is equal to number of carriers per unit volume into drift velocity into electron charge into area. If you want, you can take area below, and I by A actually becomes J, which is current density. This is the current density formula, which you should know. Also remember one more thing, J and rho are related to each other by like this. Just like you have V is equal to IR, instead of voltage you have electric field, instead of current you have current density, and instead of resistance you have rho. So this is also a very important formula which is equivalent of Ohm's law. Okay, so E is rho J is equivalent of Ohm's law. So V is IR. It's very similar to that. Remember this formula. Next up, when you have resistors in series, understand total resistance will be R1 plus R2. The current will be same, but the voltage will be different. That's what the formula works. In case of capacitance, when you are in series, it will be 1 by C1 plus 1 by C2. Q is same. The charge on each one of them is same. The voltage difference is different. Keep this in mind. In case of inductance in series, it will be L1 plus L2, and what will be same is very important, di1 by dt, or rate of change of current. Di by dt is same across all of them. So what is different is delta V is different. Keep this in mind. A lot of people think current is same. Yeah, current might be same, but di by dt will be same. That is also very important. Next up, no, resistance is not reciprocal of resistivity. In fact, the inverse of resistivity is called as conductivity. This is conductivity. Okay, this is conductivity. Okay, don't worry about that. Last thing over here, when you have resistors in parallel, you have 1 by R1 plus 1 by R2. What is same? V is same. The voltage is same. Current is different. The current is different. Whereas in case of capacitance, the capacitance is just add. It will be C1 plus C2. Q is different. The charge on each one of them is different, but the voltage drop is same. very, very important. And in case of inductors in parallel, you have 1 by LP is equal to 1 by L1 plus 1 by L2. Again, the voltage difference is same. Obviously, they are in parallel. So, resistors and inductors are similar. Resistors and capacitors are exactly opposite formula wise. Okay, next up, just erasing this. Okay, just going to the other table. Okay, and now I'm going to write, one second. Okay, so I'm going to write gravity over here and electro over here. Now some more formulas. I'm coming to that, Bhargavi. Spring and capacitance, what is same and not, I'll let you know. Jupiter always, man. Yeah. The third C is a ring. No, Preksha, the third capacitance was for spherical capacitor. There is a shell inside a shell. So the capacitance is 4 pi epsilon naught, 1 by R1 minus 1 by R2. R1 and R2 are the radii. Okay, cool. Now, first formula that you should know in case of gravity is potential formula. In case of gravity, the way potential is defined is limit potential energy per unit mass tends to 0. Unit is joules per kg. Whereas in case of electrostatics, electric potential is defined as limit test charge tends to 0, energy by charge, but in this case it is joules per coulomb, which is also volts. So that's the formula. Now, if you have a point mass and you are at some distance, the formula for potential is minus Gm by R. That's the formula for potential. But in this case, if you have a point charge and if you are at a distance R, then the value of potential is plus K or just K Q by R. K is 1 upon 4 pi epsilon naught. Keep this in mind. The formula for potential energy between two masses M1 and M2 separated by distance R is given by minus G M1 M2 divided by R square. Minus G M1 M2 divided by R square. Similarly, in case of electrostatics, what you have is Q1 Q2 separated by R. The formula for potential energy is K Q1 Q2 by R square, where K, oops, sorry guys, my bad, it's not R square. Yeah, G M1 M2, I'll just erase it. So G M1 M2 divided by R, and in case of electrostatics, what you have is K Q1 Q2 divided by R. Yeah, so there is R over there, and here you have G, here you have K, here you have mass, here you have Q. So that's the difference. Next up, what you have? Is uniformly distributed sphere equal to solid sphere? Yes, Akhil, it is. Yes, Sanjay, even if you are a NEET student, you can watch it. Yep. All right. Next, that you have to see. Okay, let's move ahead. Let's move to potentials of shell. Remember, I have spoken about shell before, but we have only spoken about the field. Now let's talk about the potential. This is very, very crazy formula. A lot of people forget this. When you are outside a shell, the formula for potential is minus Gm by R. In case of a charged shell, shell means hollow sphere. So the formula for electric potential is Kq divided by R. The problem happens when you're inside. When you're inside, understand the potential is constant and it is minus Gm by capital R, where capital R is nothing but the radius of the shell. Keep this in mind. Same thing over here. When you are inside a shell at some distance, doesn't matter where you are, the formula for potential is Kq by capital R. It's constant inside a shell. Okay. But for a solid sphere, the formula changes little bit. So this is our solid sphere, let's say, okay, like this. Now when you are outside, the formula is still the same. There is no difference. The solid sphere behaves like a point mass, so it is minus gm by r. But when you are inside, let's see that later on. Here in this case, when you are outside, it is kq divided by r. The problem is when you are inside. When you are inside a solid sphere, the formula is slightly different. Remember, it's not constant. So in fact, the formula is minus gm by 2 capital R cube, capital radius of the solid sphere. Okay, in case you forgot what r was, so this is r, the radius of the sphere. Okay, into 3r square minus r square. The small r is the distance from the center, capital R is the total radius. That's the formula. In case of electrostatics, same thing guys, there is no difference. Like you can see, it will be kq divided by 2r cube, and you have 3r square minus r square. This is the formula. Good morning Gayatri, welcome aboard. Durga, I think you are watching it on lower resolution. You are watching it at 240p. On YouTube, you have an option to see the video in a higher resolution. Okay, you can see that. All right, so let's get moving to the next one. I'm just erasing this now. Okay, so see guys, what happens is on YouTube, I don't know whether you noticed this before. So let's say you're watching this lecture out here. So there is an option over here. Just click on this. Okay, I think I'll have to skip this ad. Only then I can do this. Okay, skip this ad. Okay, just hit over here quality. Right now it's on 1080 because my internet speed is good, but you can choose at least 720. Keep it at least at 720, then it will be nice. Okay, nice. This is screen inside a screen inside a screen. Okay, cool. Let's get going to the next one. Now, there is a very important relationship between these four physical quantities which you should know. Force, field, potential, energy, and just potential. Let me put up their symbols first. F, E, V, and U. When you go from force to field, okay, when you go from force to field or from field to force, what is the formula? Guys, if field is given, force is Q into E. That's how you go from field to the force. Q into E will give you the force. Now, if charge is positive, force and field are in the same direction. If charge is negative, force and field are in the opposite direction. Here also, when you want to go from potential to potential energy, the potential difference into the charge will give you potential energy change. Or basically, U is Q into V. That's the same formula. Charge into potential will give you potential energy. Keep this in mind. When you go the reverse way, when you go like this, then the field will become force by charge. Okay, usually people put this limit Q tends to 0 because you always use a test charge to measure the field. That's how you find the field because of other charges. You divide it by the charge and make the charge very small so that the charge's field does not create new fields. So that's why limit Q tends to 0. Same thing works here. So the potential will become limit Q tends to 0, U divided by Q. Now you can also go from here to here or from here to here. How do you do that? Well, let me show that to you. If you go from U to force, then F is minus du by dr. Force is rate of change of potential energy with respect to r with a negative sign. Same thing you can do from here to here. If you go from potential to field, field is minus dv by dr. Keep this in mind. Okay, minus dv by dr. If you go reverse, if you go from force to energy, obviously if you have to differentiate, you have to integrate if you want to go the reverse way. So that's why when you integrate, what you will get delta u is equal to minus integral f dot dr. This is the formula that you will get. In this scenario, when you go from this to this, what you will get delta v is equal to minus integral E vector dot dr. A very, very important chart. Very, very important chart for all of you guys. Yep. That's how it is. Very important chart. You can see so many formulas are there on one slide, and you can see the exact relationship between all of them. If you want, I can also put the units. This will be usually in newtons. Field, depending on whether it is electric or magnetic or gravitation, it will be in Newton per coulomb or Newton per kg and all of that. Energy is in joules, and this will be in joules per coulomb. That's how it will work. So those are the units. Great. Yes, Akhil, I just mentioned that uniformly distributed sphere is equal to solid sphere, assuming that solid sphere also has uniform distribution. Yeah, okay. Let's get going to the next one. Okay, going back now to here. All right. Now, some more interesting things. You are seeing that complete electromagnetism is being covered right now. This is electrostatics and this is magnetism. Now let's talk about dipoles. If you have a negative charge here and a positive charge here separated by distance of L, then the dipole moment is given by Q into L. This length vector is always from negative charge to the positive charge. So this is the dipole moment. In same way, in case of magnetism, you have south pole and north pole. South pole has negative M charge, magnetic charge, and this has positive M charge. This is the length of that magnet. So magnetic moment is small m into L. The small m is the pole strength. This is the pole strength. Understand that. Similarly, instead of a bar magnet which has south and north pole, if you have a coil which carries current, okay, if you have a coil which carries current, that also has north and south pole. For that case, magnetic moment is NIA. N is number of turns. Remember, whenever you use capital N, it is turns. When you use small n, it is always turn per unit length. Okay, number of turns per unit length. So capital N is always used for total number of turns. Okay, so this is the formula. A is the area vector. Area vector is this vector. Okay, standard formula which you should know. Now, next thing, Anirudh, I have not planned how long this session will be, but easily 1 to 2 hours minimum. You can take it for granted. Just focus on the session, guys. I mean, even if I take 3 hours, it should be worth it because I am revising the entire formulas which you on your own would do it in the wrong way. So learn it the proper way. Okay, since I am spending my Sunday with you guys. Okay, next up, torque formula. When you place a dipole in some external electric field, then the torque experienced by it is given by P cross E, and the potential energy is given by minus P dot E. Lot of people forget that negative sign. Same thing in case of magnetism. If you have a magnetic dipole here and magnetic field in this way, the torque is given by M cross B and energy is given by negative M dot B. Very, very important formula. Again, if you have a dipole P and you are at some distance, let's say R, and this is angle theta, then the field and potential at this point can be found. What's the formula for field? The formula for field is 1 upon 4 pi epsilon naught dipole moment divided by R cube. Yeah, there is a R cube here, not R square. Be careful. And you have root 3 cos square theta plus 1. This is the formula. And remember, guys, the field will make some angle alpha with this line. And that angle alpha can be found out by this formula. Tan alpha will be tan theta, the whole thing divided by 2. That's the angle alpha with the relationship to theta. That's the formula, guys. And same thing is also valid in this case. If you have a magnet, bar magnet placed this way, and you are at a distance r, then the magnetic field is given by mu naught by 4 pi. Here you have m divided by r cube, and here you have 3 cos square theta plus 1. Same formulas are valid. Similarly, Navrata, whatever doubts you have, you can ask me later on also. And even if you have not attended previous sessions, it's okay. You watch this lecture live and later on you watch the previous sessions. The potential formula is given by 1 by 4 pi epsilon naught, and you have P cos theta by r square. This is the formula for potential. Same thing in magnetism. That's why I'm doing both chapters together. I hope you see that. And this will be mu naught by 4 pi, and you have m divided by r square. Guys, aren't you seeing that when you study both chapters together, you are seeing the relationship between them, you are seeing how they are related, and it's like in one stone you are hitting two birds. All right, great. Let's get going to the next one. All right, I hope you have written down all the formulas, guys, because these are very, very important formulas. I'm revising all the formulas by relating all the chapters. Okay, so Bhaskaran, you need to attend mock tests, you need to attend our live sessions, you need to attend regular classes through which you see the teacher solving the problems. Only then you will get a very good understanding of how to apply these formulas. Similarly, next step which we need is basically, again I'll put Electro, and then I will have Magnetism. Now, if you have some material, with dielectric strength K, okay, then that K is called as the relative permeability, which is also epsilon by epsilon naught. This is for that particular medium. This is the dielectric strength. Very, very important. Similarly, in magnetism, if you have some matter, okay, if you have some material, that will have something called as the relative permeability, and that is permeability of medium upon permeability of free space. This mu is for that particular medium or for that material. Mu naught is for free space. And guess what? This mu relative is 1 plus x. This is your susceptibility. This is your susceptibility. Okay, very, very important formula. This is from the chapter of magnetic properties and all of that. And this susceptibility, this value of x, okay, is actually I divided by h. What is I? Intensity of magnetization. So this I is actually magnetic dipole moment per volume. So this is magnetic moment, okay, per unit volume. That's what H is, I is, and this H is magnetic intensity, which is external field divided by mu naught. Standard formulas which you should know, guys. Very, very important. Okay. So, why not 2L, Swati? 2L leads to a lot of confusion. That's why I use L. Lot of textbooks use 2L. They divide the total length into L and L. It's confusing. The length of the dipole will be given and you will be like, what should I put L in the exam? You'll get confused. That's why I use L. It leads to a lot of confusion when you use 2L. Okay, avoid that. One more thing, whenever you have a material which is dielectric, it will get polarized and there will be induced charges when there is external field. So the value of these induced charges, the value of the induced charge is given by, what is the formula? The charge into 1 minus 1 by K. You would have seen this formula in capacitors. This is very important. This Q is your actual charge, okay, and you will have induced charge is equal to 1 minus 1 by K. Very, very important formula. Okay, cool. Let's get going to the next one. Okay. Previous slide, M cos theta or M. Oh, is it in the previous slide? if I have put m, then please correct it. V is, you know, 1 mu naught by 4 pi. It's m cos theta divided by r square. Okay, so potential formula due to a dipole is mu naught by 4 pi m cos theta. M is magnetic moment, r is the distance, theta is the angle at where you are standing. So it's m cos theta by r square. Okay, cool. Thank you. Okay, let's get going to the next one. Now we are going to compare these two chapters. Look at this. This is magnetic effect and sources, and here you have EMI. All right, here you have EMI. Okay, so in magnetic effects you have force is charge into velocity cross B, but and when you, this is on a charge which is moving, but when you have a current carrying wire, then the force acting on it is IL cross B. In case of EMI, when you have a wire of length L which is moving, there is EMF which is developed across it. That EMF is L vector dot V cross B, standard formula. It's a scalar triple product, L dot V cross B. That's the EMF introduced across the ends of a moving conducting wire. Also, when you have a curved wire, okay, which is carrying current, the force acting on it is same as the force acting on a straight wire. So the force acting on a curved wire is the same as the force acting on a straight wire when, you know, B is uniform or basically constant. So curved wire and straight wire between the same two endpoints experiences the same net force. Here also the formula is same, or the theorem or property is same. If you have a curved wire and let's say it is moving with some velocity, the EMF introduced across the ends across that curved wire is the same as the EMF introduced in a straight wire, which is moving in a, again, uniform field. This is very, very important. Same EMF will be introduced between the 2 points. Is that clear? Great. Yeah, very good, very good. So keep this in mind. Very, very important formulas. If you have written it down, then let's go to the next formula out there. Okay, come on. Let's get going. Don't worry, Ruchita. Physics might be tough, but you have to do it, and we are here to help you out. Okay, so don't worry, just keep attending. Whatever you don't know, you will revise it later on. All right, Hasini, very good. Namrata, very good. Sanjay, yes, says Science Priya. Okay, now, okay, let's go to this point. There are 4 laws in this slide. First is Gauss's law. So when you have a surface and you have some charges inside, okay, there might be some charges outside as well. It says that the cyclic integral of E dot dA is the enclosed charge divided by epsilon naught, where this is nothing but electric flux. This is electric flux in the closed surface. Very, very important. There is also sign convention. All the flux which goes out is positive, and all the flux which comes inside is negative. Keep this in mind. Similar to Gauss law in electrostatics, you also have Gauss law of magnetism. And what is that? It is very similar. B dot dA will be 0. Yeah, B dot dA is 0. Reason for that, whenever you have magnetic field lines, they are always closed. So because of which, the moment you take any surface, the number of lines which go in and the number of lines which go out will be equal. So net flux, so this is nothing but your magnetic flux. This is magnetic flux will always be 0. Total magnetic flux on that closed surface will always be 0. Keep this in mind. Similarly, if you have Ampere's law, okay, so you have Ampere's law, and what is Ampere's law? Again, you have some wires which carry current. Some of them might be inside this loop, some of them might be outside this loop. So these are currents, okay, and this is your loop. You take it, any imaginary loop. Then cyclic integral. Instead of electric field, you have magnetic field. Instead of area, you have length. A is going to be mu naught into I enclosed. That's the formula. Very, very important. Remember, this B is due to all in and out currents. This is not because of only inside currents. A lot of people get this wrong. The value of this integral depends on enclosed current. But the value of B at any point is because of in and out, both of them. Same thing is applicable over here. Yeah, same thing is applicable over here. Similarly, guys, like you have Ampere's law, you have Gauss's law, there is the last law which is very important in electromagnetism, and that is your Faraday's law. So you have your Faraday's and Lenz's law together, and it is induced EMF is d phi by dt. This negative sign that you see over here talks about Lenz's law. It says that the induced current or EMF is always opposite to the change of the flux. It opposes the change of the flux. Very, very important. So this is rate of change of magnetic flux, obviously. So rate of change of magnetic flux gives you induced EMF. Very, very important. All these four equations together are called something. By the way, you can also write this as integral, cyclic integral, electric field dot dl, because this is induced EMF in a loop, right? So you have a loop where you had that magnetic field lines which were changing. So you had magnetic field which was changing, you had flux which was changing. Okay, so I'll just put flux over here. So what are these four equations together called? So Nagamani, you need to remember the formulas by relating it to each other. Remember that. If you remember it separately in isolation, you will never remember it. The way I am following, the flow is very important. With practice, you will remember this. Yeah. What were all these formulas called together? They were called as the Maxwell's equation. Yeah, they are called as the Maxwell's equation. Keep this in mind, okay? Okay, chalo. Let's get going to the next one now. If you have written this down. Great. Yes, Maxwell equation, Shivam. Very good. Very good. Okay. Now we'll slowly move out of electromagnetism. A lot of electromagnetism has happened. Now we'll go to mechanics and electromagnetism. So let me just put over here. Yeah. So here you have translation. Here you have rotation. And here you have electromagnetism. Let's start with the first term. In translation, you have something called as the position. In rotation, you have angular position. In electromagnetism, the equivalent of position is basically charge, which is Q. Change in the position is called displacement. So S is delta x. This is angular displacement. And here you have the change of charge, which is also the flow, how much charge has flown, which will be delta Q. Okay. Next, you have velocity. You have velocity, which is dx by dt. Here you have omega, which is d theta by dt, which is angular velocity. And here you have current I, which is dq by dt. Very, very important. Similarly, acceleration. A is dv by dt. Here you have angular acceleration, which is d omega by dt, and here you have rate of change of current. That's it. There is no name for it. It's just rate of change of the current. So that's what you call it. Very, very important. Now, once you have got till here, there are also some additional formulas to relate this and this. Like, if there is an arc, the displacement will be given by r del theta. Velocity will be r omega, and acceleration will be alpha into r. So every term over here, when you multiply by r, you are getting this term. So theta into r, displacement, omega into r, velocity, alpha into r, acceleration. That's how it works. Very, very interesting, guys. Now, once you have studied this, okay, let me just erase. You have the kinematic equations, and they are valid only in one scenario, when the acceleration is constant both in magnitude and direction, or here in this case it's angular acceleration is constant. So only when they are constant in magnitude and direction the kinematic equations are valid. The first one being V is u plus at, S is ut plus half at square, and if you want to put it in vector form, put it like this, and here you have V square is u square plus, just put u square properly, so u square plus 2a vector dot s vector. This is very important. There is a dot product here. And the last one, displacement in nth second, is u vector plus a vector by 2 into 2n minus 1. Okay, that's the formula. Now the same formulas are also valid over here, guys. You will have omega final is omega initial plus alpha delta t and all of that. So those are standard. Everything has its own equivalent in rotation. Is that clear? Okay, I hope this is clear. Now you might be like, sir, what if acceleration is not constant? Well, okay, if acceleration is not constant, then refer to this chart. Always it will work. XVA, instead of x you can also put theta and omega and all of that, and I have given this many times before. So find dx by dt, which is the slope, that will give you instantaneous velocity, and find dv by dt, that will be again the slope of velocity time, that will give you acceleration. Here you find the area, which is integral a dt, which will give you velocity. So from acceleration to velocity, and from velocity to position, again find the area under velocity time, that will be integral v dt. So that's what you will do in case acceleration is not constant. Basically you need derivatives. Also certain times you will need this rule where you might be doing this, where you replace acceleration is dv by dt using chain rule. Very, very important. Sometimes it is needed, and you write it as dv by dx into dx by dt, and remember dx by dt is velocity, so it will become dv by dx into velocity. So this conversion also you should know for derivatives. Very, very important chain rule formula. Okay, let's get going to the next one. Okay. Guys, I hope you have smashed the like button to show your love and support, because I need your energy. Via your support, share this session with your friends. If your friends are sleeping, wake them up and get them over here. Okay, we need to make sure that we all are motivated. You are motivated, I am motivated, I am full of energy, you are full of energy. That's how it is. Yes, Harish, most of it will be covered, bacha. Mainly I am focusing on what are the tricks that you can use for solving the problems and remembering the formulas. Okay, chalo, let's get going to the next one. Again, you have translation, here you have rotation, and here you have EM, electromagnetism. Now in translation, inertia is measured by mass. In rotation it is I. In electromagnetism it is inductance. Keep this in mind. Okay, very, very important. Next is force. It is F in translation. In rotation, it is moment of force, which is nothing but torque. It is tau. In electromagnetism, it is nothing but EMF, which is E, or voltage. Yeah, very, very important. Next, you have momentum here, which is P. Here you have angular momentum, which is L, and here you have flux, which is phi. Now there are relationships between all of them. You will see how. See guys, force is mass into acceleration. What is the equivalent of mass? Moment of inertia. What is the equivalent of acceleration? Alpha. See how the equations are working. Here, what is the equivalent of mass? That's L. What is the equivalent of acceleration in electromagnetism? Recollect charge, dq by dt, d square u by dt square. That is the second derivative of charge, which is first derivative of current, L di by dt. This is also a standard formula, E is L di by dt. Similarly, next up, momentum is mass into velocity. In angular momentum, angular mass into angular velocity. Similarly, in electromagnetism, phi is mass, which is L, into velocity's equivalent is current. Recollect, mass is very similar to inertia, which is inductance. This is inductance. Okay, inductor has the same property as inertia in electricity. And velocity is similar to current. I hope you remember that. Charge is similar to x, dx by dt is similar to dq by dt, which is velocity. So that's current. Okay, very, very important. Now there are also individual formulas which you should know. I is nothing but integral r square dm. Torque is nothing but r cross f. And angular momentum is nothing but m r cross v. These are the standard formulas which you should know. Okay. Similarly, these are individual isolated formulas. Similarly, you have energy related formulas, like a mass which is moving has energy, kinetic energy half mv square. A mass which is rotating has half I omega square. Do you see the relationship? Instead of mass, you have moment of inertia. Instead of velocity, you have angular velocity. And similarly, here you have half. Instead of mass, you have L. And instead of velocity, you have current. So half Li square. That's how it is. Okay. Only study, like I have already mentioned again and again, we'll start it only after 2021 third attempt is over. So we need to make sure all the 2021 students pass very nicely with good marks and good percentiles. So you will have to wait for that. Meanwhile, remember also there is a KVPY batch which will start even in your regular pro subscription. So if you are in a pro subscription, the regular batch will also start. All right. Great. Let's get going to the next one. Cool. Okay. Now, okay, I don't want to erase this as such. Okay. Now, we will also bring in SHM over here. When you have a spring and a mass, okay, which oscillates, here you have a torsional pendulum, okay, and here you have an inductor and capacitance. First of all, the equivalent of spring constant, this is spring constant. Here you have torsional constant, okay, and here you call it as capacitance. And the equivalent of torsional constant or spring constant, remember, is 1 by C, or C is 1 by K. It always is inverse. So capacitance is inverse of spring constant. Just keep this in mind. Now you will see how it works. The time period of oscillation is 2 pi under root mass by spring constant, standard formula. For torsional pendulum which rotates like this, the time period is 2 pi under root. Instead of mass, you have moment of inertia. Instead of K, you have torsional constant, over here. The symbols are very similar. In this case, for LC oscillation, it is 2 pi under root. Instead of mass, you have inductance, and instead of K, you have 1 by C. So that 1 by C will go up and it will become 2 pi under root LC. That's how it works. Very, very interesting formula. Although there are some special formulas for simple pendulum and all of that. So for simple pendulum, standard formula 2 pi under root L by G is what you should know. And for a physical pendulum, also you should know the formula. It is 2 pi under root I by mgd. That's also a standard formula. What is this distance? That's the distance of center of mass from the hinge, wherever you are hinging it. So that's the distance which you should know. Now, in case you're wondering what these torsional constant, spring constant formulas are, well, let me tell you. F is kx. That's the standard formula. In case of torsion, its torque is equal to k into theta. If you rotate it, the restoring torque is k theta. Here the restoring force is kx. I'm ignoring the minus sign, that's okay. In case of capacitance, remember the equivalent of force, torque, is voltage. So V is equal to, instead of K, you will put 1 by C. And instead of theta, you will put charge. Isn't this the standard formula? Q is equal to CV. Q is equal to CV. That's the standard formula. There is nothing great about it. You can see the resemblance very clearly. Now, last thing before we go ahead is, I'll just probably erase this now. Okay, is damping. Whenever you have a mass which moves, the force of resistance is proportional to velocity. That B is basically called as your damping constant. Same way, if some body is rotating, okay, with some velocity, there will be a torque to stop it. It will try to drag it. That will be also B into omega. This is again damping constant for rotation. In electricity, the equivalent is resistance. If there is current flowing, it will drop the voltage. Look at this. Force. What is the equivalent of force? Voltage. What's the equivalent of velocity? It's current. And the equivalent of this B over here is R. So this is nothing but your Ohm's law. You can see that. This is Ohm's law. That's how things are related to each other. How many of you knew this from before? How many of you have learned many new formulas and you're surprised that your coaching or whatever did not teach you all these things? Please put up a surprise smiley if you're surprised. If you're not surprised, just put a flat smiley. I'm like, okay sir, I know all this. Okay. Arjun is not surprised, very good. Acha, no, I'm surprised, he says, okay. Arjun's head has exploded already. The relations are surprising, very good. Okay, interesting. Okay, chalo. Let's get going then. Very good. Now you will see something interesting. Let's go here. How to calculate damping constant, Badri? It will be given. Or other things will be given, like force and velocity will be given. Don't worry about it. Don't worry, Trimbak. We are there. Tomorrow also I'm going to be there for Sure Shot 60. Just stay calm. Okay, just stay calm. Don't get nervous. It's okay. You also have one more attempt. Don't worry. You will do well. All of us are nervous. Even I am nervous because of you. Okay, chalo. Now let's talk about circular motion. Circular motion. Standard formulas first. Okay. So if this is radius r and if this is velocity v, this velocity is omega into r, where this is omega, angular velocity. But in vector form, remember v is omega cross r. Actually speaking, omega vector is coming towards you. Use your right hand fingers, thumb comes towards you. So thumb is coming towards you, that's the omega vector. Now omega vector cross r. So omega cross r, gives you velocity, which is in this direction. So this is your r vector. Okay, that's the first formula. Next formula that you should know is basically accelerations formula. There are two kinds of acceleration. This is AC and there is another acceleration which is AT, and this is the resultant. Remember, centripetal acceleration is responsible for direction change, and it is given by v square by r or omega square r, one and the same thing. Tangential acceleration is responsible for only changing the speed, and this is just dv by dt. Very, very important. Rate of change of speed. This is only speed, understand, there is no bar there. Now when you take the resultant, A is root of AC square plus AT square, that will give you the total net acceleration. That is the vector sum of this and this using Pythagoras, as simple as that. And this acceleration is dv bar by dt. Please understand, because acceleration is rate of change of velocity. So total acceleration has the vector symbol. Tangential acceleration does not have that vector symbol because it is only responsible for changing the speed. You can see it's only in the direction of velocity. It can change the speed. Centripetal will change the direction of the velocity. That's what happens. Next up, force. There is this tangential force, centripetal force, and obviously the net force. All of them have similar relationship. Centripetal force is mass into centripetal acceleration. That's Newton's laws. Tangential force is mass into tangential acceleration, and total force, which is net force, like this, Fc square plus Ft square, will be total mass into total acceleration, one and the same thing. So that's how the relationships are for circular motion. Now keep this in mind. Whenever they will ask you a question of finding radius of curvature, just use this formula, because this r will actually give you radius of curvature. So if you know acceleration and velocity, you can easily find radius of curvature. There is no need to remember complex mathematical formulas for radius of curvature. Keep this in mind. Okay, let's get going. Very good. Thank you, Ankit, so much. Parth, it's not about my preference. It's about this channel being for English medium students. When you grow up in life and when you go to IIT, the medium of instruction is English. When you join a job, the medium of instruction is again in English. When you travel abroad, you will need English. When you are going to interact with a lot of people out there, all the decision makers, all the CEOs, all the managing directors, all the bosses out there, it's going to be again in English. So that's why you need to build up that habit of conversing in English in day-to-day life. Plus number two, if you are an English medium student and you are studying in Hindi, then you are not doing justice to your medium. So that's why we have started this English medium channel, not just for those students who do not understand Hindi at all. This is not a channel for those students who don't know Hindi only. This is a channel for all the students who also know Hindi, who also know other languages, but who are studying in English medium and they want a channel who teach all these topics in English. That's the reason for that. Yeah. Okay. Chalo, let's get going to the next one. Tarun now wants Tamil. Now Tarun, now everybody will ask, India is a diverse land. There are so many languages. Tamil is there, Assamese is there. An Assam guy will come, sir, we want Assamese language. Then Telugu guy will say, sir, we want Telugu, we want Marathi, sir, we want Goan, sir, we want Portuguese. Guys, there will be more teachers on YouTube who are teaching in all the languages than actually teaching in the regular paid platform. Punjabi, yeah. And dubbing, oh my god, crazy. And don't talk about dubbing. Dubbings are very crazy, guys. If you see any dubbed movie, it's very funny usually. Especially when you know both the languages. When you don't know one of the languages, it's fine. You won't make out a difference. But I have seen this. I mean, like, especially when you watch English movies in Hindi, or let's say you know Tamil and Hindi, okay, and you see a Tamil movie in Hindi, then it sounds very funny. So that's how it is. Okay, cool. So let's get going. Okay. Now, next important thing which you should know is for a vertical circular motion. Let's write this down. For vertical circular motion. First important formula. If you want to throw at the bottommost point a body in vertical circle so that it completes the circular motion, the minimum speed required is root 5 gr. Root 5 gr, so that as it goes up the speed reduces but does not become 0. At the topmost point it becomes root gr. This is in the case of string or surfaces. Whenever there is a string pendulum or there is a surface, there is a car given and the track is given like this so that it does not lose contact. So that's when you use this formula. There is another formula you might have seen where the speed is little bit less, root 4 gr. So as it goes up the speed reduces and becomes just 0 at the topmost point. This is the formula which you should use for rods so that it goes till the topmost point. Similarly, you have one more formula where you throw the object with only root 2 gr speed. When you do it with throw it with root 2 gr speed, it will only reach here. It will stop over here. Yeah, it won't be able to go up. So for the body to just reach till the horizontal level, come back and again go here. So the speed at the bottommost point is root 2 gr. Very, very important formulas. Okay, great. Hold on unknown. We'll do everything. AC, BC, DC, everything we'll do. Hold on, just hold on. Okay, next up. SHM. Let's talk about SHM related stuff. Simple harmonic motion. Okay, now the way we should look at SHM is, when you have an object going in a circular path, the shadow of it as it goes, the point where the projection is, okay, so when it reaches here, that shadow oscillates, so that is the SHM. So that's the starting rule, remember. So SHM is nothing but the shadow or projection of uniform circular motion. Okay, so let's do this. Very simple. Let's say there is a particle here at t is equal to 0. This angle is the initial position of that particle, and that particle moves with angular velocity omega. It's performing uniform circular motion, right? So after some time it reaches here, okay, at t is equal to t. The new angle which it has moved will be velocity into time. So this angle will be phi plus omega t. Now when you drop a perpendicular, this is the point which is moving. So this is x coordinate of that particle, which will be, if the radius is a, okay, so what is a? It's the radius. Then you will see this value will be equal to a. This is phi plus omega t, if you understand this, because this is phi plus omega t, this will be also phi plus omega t, alternate angles, a sine omega t plus phi. This is what you're going to get. Oops. A sine omega t plus phi. Yeah, this is the formula. Now, even this particle which is going in circular motion will have some velocity. This velocity will be a omega. So you will see that this particle over here will have some velocity which is given by derivative of this, derivative of dx by dt. So dx by dt is derivative, which will be a omega cos omega t plus phi. That's the formula. Now there will be also acceleration, which you can differentiate and figure out, and this will be equal to minus a omega square sine omega t plus phi. Now what are these angles called? Very, very important. This phi is called as the phase angle, initial phase angle. Phi plus omega t is called as the phase. This thing which is rotating, can you see that? This thing which is rotating, this is called as the phasor, and this diagram is called as the phasor diagram. That's what you call it. Similarly, you also have energy related equations over here. Kinetic energy of SHM is half mv square. Potential energy for spring mass system, which is oscillating, is half kx square. But when you add the total, and when you add them and get the total energy, you will get half k a square. What is this a? It's the amplitude of the oscillation. The same a which is there over here. It's the amplitude. Also, there are some more equations which you should know, like acceleration in terms of x is minus omega square x, and velocity is omega root a square minus x square. These are also very important relationships when you don't want velocity and acceleration as a function of time, but you want it as a function of x. So this is how it looks like. Very, very important formulas for SHM. Okay, cool. Let's get going. What is the physical significance of phase angles? It helps us relate the SHM to a circular motion, which makes the problems easier. So when a problem involves oscillation, you can think or convert it into a circular motion problem and then solve it, which might make it look easy. That's the whole point. Okay, cool. Now you will also see the importance of phase in AC, alternating current. Alternating current, very, very important. So if you have an inductor, a capacitor and a resistor connected to an external voltage, let's say E naught sine omega t, okay, I don't know, plus phi, okay, and there is some current flowing through it. This current is I naught sine omega t. What is this phi, you might be wondering? This phi is nothing but phase difference between voltage and current in AC. In AC, voltage and current do not increase and decrease simultaneously. There is a phase difference between them. Each one of them will have some voltage across them. Let's say VL naught, VC naught and VR naught. Why am I putting naught? That naught stands for maximum values. Maximum voltage across L, maximum voltage across C, maximum voltage across R. So that's why that naught. So like you can see over here, this E naught stands for amplitude. This is the amplitude or max value. This is the max value. In fact, you would have also studied RMS value. Like RMS value is the max value by root 2 for a sine kind of voltage. So E naught by root 2. That's the formula for RMS voltage, RMS current, everything. It works. Now, why I have drawn this circle? Because of phasors. Remember this sentence, love is above all. Just remember this. From this statement, you will remember XL is on the top. Obviously, XC is below, love L is on the top, and R is towards your right, R for right side. So that is XR over here. These are three vectors. When you, oops, sorry, this is just resistance, my bad. Yeah. So when you take these three vectors, you take the resultant, what you get is Z. Now what is this XL? This is reactance. It is the equivalent of resistance for inductor. This is also reactance for capacitor. Okay, this is capacitive reactance. And what is this Z called? This is called as impedance. This is called as impedance. Keep this in mind. And this is that same phi which you are looking for. That phi over here and here is same. In fact, you can also write that the value of Z will be, first take care of this. This is XL, this is XC. So subtract them. So you will get XL minus XC on the top. Okay, XL minus XC. And this is R and this is XL minus XC. This is the resultant. So this square plus R square. That's how it works. Similar graph you can draw. Similar phasor diagram you can also draw for voltage. This will be VL, love is above all. this will be Vc naught, okay, VL naught, Vc naught, and this will be Vr naught, and their resultant will be that E naught. That's what it works like. So again, if you want to write E naught, it will be root of, first take care of these two, so VL naught minus Vc naught whole square plus R square. That's the formula for voltage. And do not forget, current is always here. This is where current is. So voltage and current have a phase difference of phi. This is how it works. Similarly, remember one more thing. Any voltage is current into resistance. Example, total voltage is current into total resistance, which is called as impedance. Voltage across resistance is current into resistance. Voltage across inductance is current into inductance's resistance, which is called as reactance. So XL. Voltage across capacitance is current into XC. So Ohm's law is valid for individual parts or the entire entity as a whole. So it depends what you take. If you take resistance, voltage across resistance. If you take impedance, total voltage. That's how it works. Last thing over here, at resonance, very, very important, at resonance, the total impedance is R because the value of phi is 0. And at resonance, current is maximum, very, very important. One last thing before we end the discussion and go to the next part. The power value, the power loss is given by Vrms, Irms, cos phi. Very, very important, where cos phi is called as the power factor. Very, very important formula for power in AC circuits. And this is also given by Irms square into just resistance. Okay, so you have the entire AC on this slide. Do you love this slide? If you love this slide, please put up a like in the comment section below. Just put up a thumbs up, hit the like button, and also show a yo in the chat box. In the total voltage formula, I squared IR whole square should come. No, this is fine. This is entirely under the root. You can see that there is a root over here. That's fine. Yes, great. Let's get going to the next one. Okay, let's get going, guys, to the next one. Okay. Now, next up is, we are going to solid mechanics. We are doing chapter by chapter, and we are sometimes clubbing the chapters also, like you can see. I want to do longitudinal, shear and bulk together. Well, longitudinal means when you have an object and you pull it and you will see that the length changes. Shear means you have an object, you apply force like this, so the shape changes this way when you pull it like that. And bulk means you have an object and the volume changes. There are volume deformations because of the changes in pressure maybe. So there are three kinds of stresses based on three kinds of deformation. So first is shear stress. This is stress. Stress is the force which is perpendicular to the surface. You can see this is the perpendicular force divided by area. Shear stress. Shear stress. You can see this is the parallel force. So this is parallel force to the area by area. For volumetric stress or bulk stress, okay, so that bulk stress is just change in the pressure. Keep this in mind. Just change in the pressure is called as bulk stress. Next up, strain. Strain is epsilon naught. Oops, I think I had put up shear over here. My bad. This is longitudinal. Okay. Next up. So strain longitudinal is how much did the length change divided by the original length. In case of shear strain, It's how much did it move, which is x, divided by that height, which is also, if you take this angle, it is tan theta. This is theta. In case of bulk, the bulk strain is change in volume by original volume. That's how it works. Last formula, modulus. Young's modulus is that stress by strain always. So this is Young's modulus. Young's modulus, force by area, which is stress by strain, which is delta L by L. In case of shear, you have rigidity modulus or shear modulus, which has the symbol G, and that is again stress, same thing guys, F parallel by area by tan theta or x by h, whatever you want. For bulk, it is B is equal to delta P, which is shear, which is bulk stress, by bulk strain, which is delta V by V. There is a small catch, there is a minus sign in order to make it positive. Okay, I have explained that before why that minus sign should be there, but remember minus sign is there in the last formula. Okay, write it down. Now, where is that empty slide? Yeah, I wanted this. Going on to surface tension. Yep, going on to surface tension now. Now, whenever you have a fluid surface, okay, so this is the surface of liquid. It has a tendency to contract, and that phenomena is called as surface tension. Like when you spray water on the floor, it contracts it from all the sides. It wants to minimize its surface area. So always the molecules on the surface have high potential energy. The molecules in this is the surface molecules, these are the bulk molecules, they have low potential energy. So every molecule wants to go from high to low, not because of gravity, but because of the electromagnetic forces which are there in place. Now, when you draw an imaginary line on the surface, you will see there will be force on this side and that side. If this length is L, this force is F, this F is S into L. This S is called as the surface tension. Please understand, surface tension does not have the unit of Newton. In fact, it has the unit of Newton per meter. So a lot of people think surface tension is a force. No, it's force per unit length, and this force always is perpendicular to the length and it always acts along the surface. That's one formula. Second formula, because I told you it has that extra energy, their difference, which is U, is called as the surface potential energy. So U is the surface potential energy, and USA, that's the way to remember, USA. What is A? It is the area. It's that area of that surface. The energy of the surface is S into A. This can be used for solving problems which involve a bubble is there, the surface area increases, how much energy is needed and all of that. Because then delta U will be S delta A. Change in area into surface tension will be change in energy. So that will give you the work done to change the surface. So that's the formula which you should know. Alright. Now, apart from this, you should also know height rise of a capillary formula. Very, very important. So there you go. You have this theta over here. This theta is called angle of contact. And it could be acute, it could be obtuse, it could be 90, anything. Then this height rise is 2s cos theta by rho gr. This is the formula for height rise. I've done a beautiful question on the height rise and work done yesterday. In case you have missed the mock test, please watch it. These formulas were very, very essential. Now, the next part is where you have drops and all of that. So I'm just erasing this. You can always take a screenshot even by rewinding back. Don't worry about it. Alright. Whenever you have a curved surface, doesn't matter where is the liquid could be here or there. this is just a surface. Remember the pressure on the concave side, and if you compare the pressure on the convex side, the pressure on the concave side is more, pressure on the convex side is less. That's how it works. And that's when you get three different scenarios. First is you have a drop. Second is you have a bubble. Okay, you have a bubble in liquid. That means the liquid is outside. So this is like a bubble in some water or some oil or whatever. And last thing, this is bubble in air. So this is how it is. There is air inside and air outside. Then the pressure inside is more than the outside pressure. This is called as the excess pressure, which is given by 2S by R. So the formula is 2S by R because there is only one surface. So for one surface, the pressure difference is 2S by R. Here also you can see there is only one surface. So that's why the excess pressure is still 2S by R. But here there are two surfaces, one the inner and the second one the outer. So two surfaces. So the moment there are two surfaces, it will become 2 times 2S by R. So delta P will become 4S by R. Keep this in mind. So a lot of people get confused over here, sir, whether I should take 2, whether I should take 4, should I take S? No. For one surface, it's 2S by R. For two surfaces, it's 4S by R. Keep this in mind. Yeah. Now, let's get going. Let's get going to the next one. Okay. Cool. Now, let's move on to fluids as well. Okay, let's move on to fluids. So, the first thing in fluids, when you have a medium, okay, when you have a medium of density rho and gravity is G, then the pressure changes with height and the rate of change of pressure with height. So let's say this is dH and let's say the pressure changes by dP. This is called as the pressure gradient, rate of change of pressure, and this is minus rho G. Very, very important. This minus sign stands for pressure decreases with height. Okay, with height it decreases. That's why that minus sign. Now, if there is a surface of liquid and you go inside that liquid at the depth h, if the outside pressure is P naught, the pressure here is P naught plus rho GH. If you are inside this liquid of density rho. But the same thing, if you go up and the air's density is rho A, then the pressure over here will be P naught minus rho of air GH. Notice there is a minus sign because you are going up, pressure will decrease. Keep this in mind. Also, keep this in mind, no matter what the shape of that container is or the vessel is, as long as there is air, as long as it is completely full, pressure at same height or same depth is same. So, pressure at same depth or height, whatever you can call, in same liquid is also same. Very, very important to equate pressures. And then you also get the barometer formula. So this is a barometer where you have a liquid and the liquid climbs up in that barometer. So this height will tell you what the pressure is. This is the barometer and the outside pressure is rho GH. Here the pressure is negligible, the vacuum pressure. Okay, very, very important. Its barometer is used to measure actual pressure. Similarly, you have the manometer where you pour a liquid. This side has pressure P1, this side is connected to pressure P2. So there is difference of heights over here, like you can see in that liquid. So this is P1 minus P2 is equal to rho GH. Very, very important. Great. Okay, let's get going to the next one. Okay, I hope everybody is clear about this. All right. Now in fluid statics, the next important formula that you should know is for buoyant force and all of that. So if you have a body which is submerged, this much part, let's say, is submerged. This is Vs, submerged volume. Then the liquid will apply forces like this. The resultant of all these forces, so this is dF, let's say, the summation of dF or integral of dF, which is F, this is called as the buoyant force. This is called as the buoyant force. And the formula for buoyant force is Vs rho G, standard formula. Volume of the solid submerged, rho is not the density of solid, keep this in mind, this is the liquid's density. Now, one thing you should know is that when you immerse a solid, because of the upward force, buoyant force, the weight of the solid reduces apparently. Hence, you get the apparent weight formula, which is actual weight minus the buoyant force. This is standard, which you should know. You can also use this fact that when you have a solid submerged inside a liquid, okay, then if, for example, the liquid's density is 1000 and solid's density is, let's say, 800, then remember one thing, if solid's density is 800, then almost like 80% will be submerged, and only 20% will be on the top, because 800 by 1000 is 80%. So this is how you can solve the problems within seconds. So the ratio of the density should be calculated. Density of solid by density of liquid. That's 80%. So 80% is submerged. If this was 700, then this will be 70% inside, 30% outside. So this helps you solve the problems quickly. Going ahead. Next, for viscosity. Standard formulas. If you have layers sliding over each other and each layer has a different velocity and there is some separation dh, first thing, velocity gradient. Velocity gradient is change in velocity by separation. And you have Newton's law of viscosity. And it says that each layer will experience a drag force, and that drag force will be given by eta A dV by dH, which is velocity gradient. And what is this eta? This is viscosity. This is viscosity of the liquid. Very, very important. Then the next important, these are all very important. Every time I have seen there are questions which come in the JEE Mains. If you have a ball which moves of radius r with velocity v, then it also will experience a drag force, and that drag force is given by 6 pi eta r v. And what is this called? This is called as Stokes' law. And when you have drops falling, eventually it falls down with terminal velocity. This terminal velocity is constant. Eventually it falls down with terminal velocity. What is the formula for that? 2 by 9. What is similar to 9? G. So G comes on the top. Okay. And then you have eta over here, you have r square over here, and difference of the densities. Sigma minus rho. You might be wondering what is sigma, what is rho? Rho is the density of the air outside. Sigma is the density of the drop over there. Okay. So that's what happens. This is the formula. Okay, great. Let's get going to the next one. Very, very important formulas, guys. Okay. Next up, fluid dynamics. Fluid dynamics. Okay, very, very important. Now in fluid dynamics, what do you have? First of all, the equation of continuity, and which is nothing but A1 V1 is equal to A2 V2, and the rate of flow. The rate of flow of any liquid which flows through an area A is A into V. So this is basically the liquid which goes in and the liquid which goes out should be equal. Next important formula which many people do not know: if you have liquid of density rho coming with speed V falling on an area, it will apply a force which is called as the thrust force. This thrust force is given by rho A V square. Very, very useful for solving pipe problems where you have a pipe and it bends and the question is what is the force acting on the pipe? Rho A V square, find the resultant of that. Or you have a U-shaped pipe and you have to find what is the force by water because it turned, or just water is falling on a wall, what is the force? So this is very, very important. Lastly, you have Bernoulli's equation and its application. So for Bernoulli, okay, Bernoulli's equation, pressure plus rho GH plus half rho V square is constant. What it means is, if you have a pipe like this, you measure the pressure here, H here, velocity here. Find this term. Measure the pressure, velocity, height over here. Find this term again. The sum of these three will always be constant. For any section, you can take multiple sections, no matter where you take it, P plus rho GH plus rho V square is constant. Keep this in mind. Yes. Similarly, you have, if you have a liquid full of, a container full of some liquid and you make a nozzle, it will come out with some speed. That speed is root 2 GH. What is H? H is height measured from the top. Remember that. This is H. And where it falls, this range is given by 2 root H into this total height H minus H. This is the formula for the range where the liquid falls on the ground. Very, very important. Okay, there we go. Okay. So, transverse waves, transverse, longitudinal, and electromagnetic waves. Electromagnetic waves. First thing first, in a transverse wave, the particles are moving like this, whereas the wave is going along the x-axis. The wave is moving this way. In longitudinal, the particles of the medium are moving back and forth, and the compressions and rarefactions are also moving in the same direction. So the compressions and rarefactions are moving parallel to the wave velocity. In electromagnetic waves, you have electric field like this and you have magnetic field which is perpendicular. So you have two waves, electric and magnetic, both moving simultaneously. What are the equations first? Equation wise, y is a sine kx plus or minus omega t. Now remember what is a and omega and all of that. This is nothing but the amplitude. This is amplitude. What is k? It is 2 pi by lambda, which is angular wave number. Omega is 2 pi f, and this plus and minus tells you the sign. If it is plus, it is going in minus x. If it is minus, it is going in plus x. Keep this in mind. A lot of people make a mistake there. In this case, the equation is displacement of a particle is maximum displacement, same thing, sine kx plus minus omega t. This is displacement amplitude along the x-axis. In electromagnetic waves, you have electric field is E naught sine kx plus minus omega t. Magnetic field is B naught sine kx plus minus omega t. Okay, keep this in mind. Very, very important. You also have wave velocity formula. Wave velocity, you can write it in general for all of them as omega by k, but for wave on a string, what is the formula? It is root of tension by mu. What is this mu? It is kg per meter, mass per unit length. For longitudinal, the formula for solid, when the wave is traveling, sound is traveling in a solid like a wall or a stone, it is bulk modulus by rho. Actually not bulk modulus, Young's modulus by rho. And for liquids or gas, it is bulk modulus by rho. It turns out for ideal gas, the bulk modulus is gamma times P. Yeah, gamma times P by rho. Gamma is Cp by Cv, P is pressure. So for solids it's Young's modulus, for liquids it's bulk modulus, for ideal gas it's gamma P by rho, standard formula. In case of electromagnetic wave, the speed is, again you can use omega by k or f lambda, whatever you want, but it is also E naught by B naught, which is also E by B, which is also 1 by root mu into epsilon. This mu is nothing but permeability, this is permittivity. So these are permeability and permittivity, that's going to give you the speed of light. Cool. Now if you take this and differentiate this dy by dt, you will get particle velocity. If you take the second derivative of this d square y by dt square, you will get the particle acceleration. This is the particle velocity and this is the particle acceleration. It will come out very, very similar to SHM, guys. So there is nothing great about it. It is like SHM. Everything else is similar. Is that fine? Shall we go ahead? Okay. Cool. Next. Okay, I'm erasing this. I hope you have copied this down. Okay, I'm going to erase this now. All right. Next up, what you have in this only. Where did my pen go? Okay, it's here only. Next up, what you have is the relationship of power and all of those things. So in transverse wave, the power of the wave which is transmitted is half mu v a square omega square. For longitudinal, you generally talk about intensity, which is half maximum pressure by rho v. Now you might be wondering what the hell is this PM? This PM, which is called as the pressure amplitude, is nothing but bulk modulus K into Sm. Very, very important. This is your bulk modulus. This is your angular wave number. And remember, this Sm was displacement amplitude. Very, very important. And in case of EM waves, okay, what do you have the formula as? The formula for intensity, standard formula for intensity, is given by half, and you have B naught and you have E naught, okay, which you can also write it as half epsilon naught E naught square into C. So both the formulas work. You can use whichever you want depending on what is given and what is not given. This is permittivity, this is max electric field, this is speed of light. Standard formulas which you should know. Great. Next, get going to the next one. If you have a crest which is incident on a fixed end, when it reflects back, then it will come back as a trough. This is very, very important. Similarly, if you have a crest which is incident on a free end, then when it reflects back, it will come back as a crest only. There is no change in phase. So that's for transverse waves. Now this same rule is applicable even for electromagnetic wave, because electromagnetic wave is a transverse wave, same as transverse. Okay, very, very important. This is same as transverse wave. For longitudinal wave, things are slightly different. If you have a compression which is incident on a wall, okay, and then you have a compression which is incident on a rarer medium. Let's say this is denser medium. Okay, this is dense and this is a rare medium. Then what happens? For longitudinal waves, the compression comes back as compression. Very important. It does not get flipped when it reflects from a denser medium. But when a compression goes from dense to rare, what comes back is a rarefaction. Okay, so keep this in mind. So only for longitudinal, it is exactly opposite of what you would get for transverse wave. Very, very important. Okay, let's get going to the next one then. You have standing waves now. So in general, you generally don't worry about standing waves for electromagnetism, so don't worry about it. So let's just probably use that division. Okay, cool. So you have transverse over here and you have longitudinal over here. Okay, great. Now what you have is, for transverse wave or longitudinal wave, the standing wave equation. The standing wave, which looks something like this. These are called as the nodes. These are called as the antinodes. And the equation for both of them doesn't matter, it's very similar. It's A sine kx, okay, cos omega t. How do you get standing waves? When you have one wave going like this and another wave going like this. So when they go in opposite directions, what you get is the resultant wave, which is the standing wave. Keep this in mind. Now you have three arrangements over here. One is when two ends are fixed. In this case, you have two ends which are closed completely on both sides. Second arrangement you will get when one end is fixed and the other end is open. In this situation, you have one pipe which is closed and this is open. And the third situation, when both sides are free on a string. In this situation, for longitudinal or sound waves, you have a pipe which is open on both ends. It's just completely open on both ends. You have formulas like this. So when it is fixed at both ends, the frequency is NV by 2L. It's the same when you are here. For this also it is same, by the way. This and this have the same frequency. F is also NV by 2L, standard formula. Same thing over here. When the pipe is open, okay, when the pipe is open or when the pipe is closed, both sides, then the formula is NV by 2L. A formula for frequency is NV by 2L. Only problem is when one end is closed or one end is fixed and other end is free or open, then the formula will become odd times V by 4L. Here also the formula for frequency will become odd times V by 4L. Okay, so keep this in mind. So that's the formula. Oh no, not 2N. Who said 2N? Now this A, oh, some of you are asking, sir, shouldn't it be 2A? Okay, this A is the total amplitude. Total amplitude. This will be twice of amplitude of each wave, of each interfering wave. Of each interfering wave. So understand, you guys make a lot of mistakes in that A and 2A. This is actually A only. This is the total amplitude of that standing wave. That is A plus A. Remember, each wave might have some amplitude. So it will get added up. Okay? I hope that makes sense. Govind, I'm doing very much fine. Standing wave is the enemy, looks like it. Somebody is struggling with drawing the waves. Okay, Navrata is back. My God, where were you? Total of, sorry boss, I cannot do that. I will continue how much ever I want. Yeah. Okay. I mean, it's very difficult to manage all of that. Okay. Hello, Surya. Will it complete before 12:30? I am hoping it will complete before 12:30. Okay. Next up, let's talk about interference. Okay. Let's talk about interference. So, 1 second, guys. This is interference. So when you have two waves, let's say this is amplitude A1, this is amplitude A2, they are separated by some distance delta x. There is a path difference between them. This delta x is called as path difference. This delta phi is called as phase difference, and this delta phi is given by 2 pi by lambda into delta x, standard formula which you should know. Okay, next up, each of these amplitudes should be added like vectors. This is A1, this is A2, and this is delta phi. Then the resultant vector gives you the net wave which is produced when you add both these waves. So the new wave which will be produced will be the amplitude which is coming over here as the resultant. So the resultant wave's amplitude, this is what you get. And the formula is standard. A is root of A1 square plus A2 square plus 2A1 A2 cos del phi. That's the formula. So give the formulas for YDAC. The YDAC, the main formula that you should remember is that when you have slits separated by distance, the fringe width that you get is lambda d by d. This is the fringe width. This is the main formula. Now there are other things like what happens when you put a slab and all of that. So that depends from scenario to scenario. Whenever you put a slab of refractive index mu, then understand there is an additional path difference of T into mu minus 1 which is produced. This slab will produce that additional path difference. Keep this in mind. Okay, let's get going. Now, having said this, let's go to this slide back and slowly we will move to optics. And here let me talk about mirrors, and here let me talk about lenses. First thing that you should know for a mirror, 1 by V plus 1 by U is equal to 1 by F. R is equal to 2F. Okay, now now what do we need? Yeah, lens के लिए है 1 by V minus 1 by U is equal to 1 by F. That's the lens formula. And what is the formula for focal length? 1 by F is equal to, what is it? Mu minus 1 into 1 by R1 minus 1 by R2. That's the formula for focal length. Okay, so let's get going to the next one. Now, magnification formula. Magnification which is perpendicular to the axis. Very, very important. A lot of people make a mistake over here. What is the formula for magnification along this direction? It's minus V by U. And magnification along the principal axis is minus V square by U square, which is also image velocity by object velocity. And same thing over here in lenses. Magnification in this direction is just V by U. There is no minus sign. Whenever you see a minus sign, there will be no minus sign on the other side. So it works opposite. And the magnification in this direction is V square by U square, which is also image velocity by object velocity. This is one thing. And power formula. So for a concave, focal length is negative, and what do you get? Power should be positive. So Power formula is minus 1 by F for mirrors and power formula is 1 by F for lenses. Now there are many more formulas out here in optics. I would say do one thing for optics because I want to go to thermodynamics. There is one interesting video which I have made. All you need to do is search for Shreyas Sir 15 minutes. Just search for Shreyas Sir 15 minutes. You will get these two chapters. Complete formulas for center of mass, momentum and collisions and ray optics. So it will take 30 minutes for you to see two videos. But in these 30 minutes, you will complete these two chapters. Complete formulas revision. So it will be better if you see these two things because I have done it very nicely, crisply in 15 minutes. Will you do that? Will you do that? Can we go to thermodynamics then? Okay, can we go to thermodynamics then? Okay, everybody with me? Okay, cool. Let's do that. Excellent. Chalo, let's go to thermodynamics. Where is my pen? Let me drink some water. Okay. Board is not clear. Bacha, just Aisha, do one thing. Just refresh your screen and just select the proper high resolution. Only then you will be able to get it. Okay. Chalo, let's get going to thermodynamics now. Now I want to go to this first. So there are four types of processes that I want to discuss. First is isothermal. Next, let's say isobaric. Then let's say isochoric. And then let's say adiabatic. Okay. Now, for these processes, remember all these rules. But before that, one simple thing. First law. So first law says Q is delta U plus W. This is in physics. In chemistry, the work is different. Understand? Always work done by the system is considered positive in physics. Okay. For isothermal, obviously temperature is constant and therefore PV is also constant. For adiabatic, PV raised to gamma is constant and you can also write PV raised to gamma minus 1 is constant. A lot of people ask, sir, how do you remember formulas? You just sing it like a song. When you keep saying it, writing it, saying it, writing it, listening, again writing, you will eventually remember. So write it 100 times, listen to it, speak about it, talk about it in your head, you will remember it. Isobaric, pressure is constant. If pressure is constant, volume is directly proportional to temperature. Isochoric, volume is constant and then you have pressure is directly proportional to temperature. Now, let's talk about the work done and all of that. For isothermal, since temperature is constant, you have delta U as 0 and if delta U is 0, Q and W will be same. So Q will be equal to W, which will be nRT ln V2 by V1. In chemistry, there is a negative sign here. Next up, over here, isobaric, work done will be just P delta V. Okay, actually it is integral PdV, but you don't have to integrate because pressure is constant. Delta U is always NCV delta T, and the work done, heat, because it's isobaric, pressure is constant, NCP delta T. Okay, isochoric, work done is 0, W is 0, so Q will be equal to delta U. So Q will be equal to delta U is equal to NCV delta T. Similarly, for adiabatic, Q will be 0. If Q is 0, delta U and work will be negative of each other. So W will be equal to negative delta U, which is negative NCV delta T, which you can write it as P1 V1 minus P2 V2 by gamma minus 1. That's how it is. I hope this is clear. Yeah, Yalini, I know my voice is not that clear because I am using a different microphone. My microphone just went bad. Let me just see if I can somehow increase this loudness a little bit. Is it better now? I don't know. Just tried something. Okay. So My battery of my, I mean, look at that. My microphone gave up, but I did not give up. My battery just died. And there are two batteries. I ordered this microphone recently, I hope you remember. And it gave up. And like, okay, Shreyas Sir is discussing everything to me. Okay. So let's get going to the next one. Alright. So I will need a blank slide now. 1 second. Let me just move ahead. Oops. Yeah. Okay. Now, slowly moving on to specific heat capacities and kinetic theory of gases. So KT, G and thermal physics. KT, G and thermal physics. So first thing, change in length when you expand something because of heating. So that will be L initial alpha delta T. Change in area is original area beta delta T. Change in volume is initial volume gamma delta T. And what you have is beta is 2 times of alpha and gamma is 3 times of alpha. That's the standard result which you should remember. Now, another important formula which you should know is for heat capacities. When you change the phase, you will use this formula. This is called as the latent heat. Latent heat, and this is for phase change. So heat supplied for phase change, solid to liquid, gas to liquid, etc. But when you change the temperature, you will use this mc delta T. You can also write it as C delta T. So the difference between these two C's is that this is specific heat capacity, and this capital C is just heat capacity. And whenever you have a calorimeter and there are some hot bodies and some cold bodies, heat lost will be heat gained, because nothing can go out or inside the system. That's the formula that you would use. Okay. Let's get going to the next one. Okay. I'll just erase this probably. Okay. If you have written this down, please put a thumbs up. Come on guys, quickly. I want to finish this in the next 10 minutes, 5 minutes. Let's get thermodynamics also done. Sunil, Vishnu, there will be no PDF, bacha. You will have to take screenshots. You have to pause and you have to write it down simultaneously when I am writing it. Because remember, I always crack this line, bachalo. Lot of people just give the notes. There is no use, absolutely no use. You will just put it in your file or put it on the wall, but it will not enter your head. When you do it on your own, only then you will be able to do it. I hope you agree. I mean, you might have seen beautiful paintings on the wall. You might even see a painter painting a beautiful painting. You might even buy a painting from a painter. That's no use. You will not learn painting. You have to pick that brush. You have to make some errors. Only then you will be able to get it. Achha. How many of you have, somebody saying already 15 pages completed? 15 pages completed. Wow, very good. I don't know. What about others? Okay, going ahead over here. Okay, first in KTG again. We're talking about KTG. RMS velocity is root 3 RT by m. This is molecular weight. Average velocity is 8 RT by pi m. Then most probable velocity is 2 RT by m. And then you have the famous equation PV is equal to 1/3 n m v square. Okay, VRMS square. P is equal to 1/3 n m v RMS square. Famous equation which you should know for KTG. And also this gamma is 1 plus 2 by F. Gamma is nothing but Cp by Cv. F is degree of freedom. Keep this in mind. And there is another relationship between Cp and Cv, and that is Cp minus Cv should be always R. Okay. And depending on what type of gas it is, you have different degrees of freedom, different gammas. So you should know for which gas what is the gamma, what is the Cv and what is the Cp. Example, if you take monoatomic gas, the degrees of freedom are 3. What is gamma? Gamma 2 by 3, so it will become 5 by 3. Cv will become 3R, Cp will become 5R. Whatever is there here will come. So whatever is there here will come here. What is there here will go there. Cp minus Cv will be. Okay. So that's what you will get. Oh, sorry. What did I do? 3R by 2 and 5R by 2. My bad. I forgot that by 2. Okay. So Cv will be equal to 3R by 2. Cp will be equal to 5R by 2. For diatomic gas, 3 translation plus for diatomic it will be 2 rotational. So totally 5 degrees of freedom. So it will become 7 by 5. And here you will get 5R by 2 and here you will have 7R by 2. That's what you will get. For triatomic linear also it will be the same thing. For both of them it is the same thing. Only difference is for tria non-linear. But you do not have it in physics, but still if you want to know, it is 6. 3 translation, 3 rotational, and then you will have, gamma is basically 1 plus 2 by 6. 2 by 6 is 1 by 3, guys. You can do that. Okay, so that's something which you can do easily depending on that what kind of degrees of freedom you have. But generally in JEE physics you will only have first monoatomic, diatomic, triatomic linear, nothing else. Okay, efficiency for Carnot engine. For Carnot engine, remember this, the cycle is adiabatic, isothermal, adiabatic, isothermal. So efficiency is 1 minus Tc by Th, and the engine absorbs something, it gives up some work, and it will reject some heat. So this QA is actually W plus whatever heat is rejected, and this efficiency is how much work is done upon how much heat is absorbed. Very, very important. Work by absorb. Refrigerator is exactly opposite of that. You will see all the formulas are, instead of in the numerator, it is in the denominator. That's it. So instead of efficiency, it is called as coefficient of performance. Keep this in mind. Okay. So, having said this, all right. Okay. Great. So you have the photoelectric equation. Next, if you have light of frequency f falling on a metallic surface and electrons getting ejected out, okay, so this is light, then the energy of photon is equal to work function plus the kinetic energy. This energy of photon is hf, work function is hf naught, kinetic energy, which is half mv square, can be also written down as EVS. Vs is the stopping potential, f naught is the critical frequency, Vs is stopping potential. Okay, very, very important. And when you move to slowly, atomic structure and all of that, the formulas are very, very similar to what you learn in chemistry also, but still I'll just give it to you. Like the de Broglie wavelength of any matter, remember, is h by p, where p is momentum. Keep this in mind. Energy of a photon, standard formula, is hc by lambda, which is also hf. Next, very important formula, what else we need? Yeah, the wavelength, for Bohr's orbit, angular momentum is nh by 2 pi, standard formula, which you should know. L is angular momentum, n is principal quantum number. And during transition, this is the formula you are going to use, z square r, and 1 by n1 square minus 1 by n2 square. Z is the atomic number, r is Rydberg constant, lambda is the wavelength which is emitted during the transition. So you have orbits, the electron jumps from one orbit to other, so the wavelength of the light which is going to be emitted. So that's the formula for that. Okay. Then, alright. Then, in X-rays, the two main formulas that you are going to probably need, one is in that graph which you have, okay, this lambda minimum, you will need this formula where electron charge into the voltage by which it is accelerated is the kinetic energy, which is also the energy of the photon which is emitted of X-ray, which is hc by lambda minimum. This is the formula you will need. Keep this in mind. How many of you remember this formula? Let me know. Some of you have forgotten. Okay. Chalo, let's get going to the last formula over here, and that is Moseley's law. Moseley's law. Moseley's law means you are going to need root of frequency. Yes, root of frequency, do not forget that, is equal to A into Z minus B. Standard formula. Moseley's law, where he plotted the graph of root of f and z and he found out to be a straight line. Standard thing which you should know. Okay, interesting. Yes, so many formulas you are learning, guys. One more, then let's go to nuclear physics. If you have written this down, okay, nuclear physics. Nuclear physics. Okay, cool. Oh my god, how many of you are there? Alright, chalo, let's get going to nuclear physics. First is when you have protons and neutrons, okay, inside the nucleus, the total atomic number is Z plus N. Atomic mass number is Z plus N. Z is number of protons and this is number of neutrons, and the radius of a nucleus is R naught into A raised to 1 by 3. This is a standard formula, and the density of a nucleus is constant. Keep this in mind. Now, whenever two or more nuclei merge together, okay, when two or more nuclei merge together or two particles merge together and they give one single particle, there is always some mass defect, okay, and you will always have some energy which is released. This is called as the mass defect. The difference of the mass. That energy which will come out will be given by Einstein's famous equation, which is delta m c square, and you can also write it in terms of atomic mass unit, which is 931 multiplied by delta m mega electron volt. You should know this formula. Standard formula. Now, when a radioactive material decays, when it decays and you have n amount of material left or nuclei left, this dN by dt, rate of decay, okay, this is also called as activity or rate of decay. So this dN by dt is minus lambda into n. You should know this formula, and when you integrate you get this n naught e to the power minus lambda t. Standard formula. The number of nuclei present after some time is initial nuclei e raised to minus lambda t. Also, you can write lambda, which is decay constant, is ln2 by t half. You should know this formula. Log of 2 by t half. Very, very important formula. Okay, so these are the main things. T half is the half-life, and you also have the average life formula, which is 1 by lambda. This is average life, this is half-life. Two things are different. Half-life is when the number of nuclei becomes exactly half of the original value. Average life is the average time for which any nuclei stays alive before it becomes decayed. That's it. Okay, that's how it is. Great. Let's get going to the next one. I think most of the formulas are done. There is one important formula which you should know from semiconductors. Semiconductors. Please remember this formula, guys. Number of hole concentration into number of electron concentration is always constant and it will be equal to number of charge carriers in an intrinsic semiconductor square. Standard formula. Very, very important. Now, this is one formula, and the second formula is the conductivity of a semiconductor is the conductivity of electrons plus conductivity of holes. This is E Ne into mu E plus charge into number of holes per unit volume into mu of holes. If you are wondering what these numbers are, E is nothing but the charge. This N is charge concentration. Charge concentration. And this mu H is nothing but called as the mobility. This is called as the mobility. Yes, mobility. Very important. A lot of questions can come on this formula as well. For transistor, for transistor, yeah, that's simple. So I emitter is IC plus IB. You should know that. And alpha and beta, the way you remember it is collector. Collector is a top government official. He is on the top, and it will be beta means IB. And same thing, IC by here it will be IB. So that's how you write. Collector is always on the top. If it is beta, it is B. If it is alpha, it is E. That's it. That's something which you can do. Okay, cool. Chalo guys. So, oh fine, Hemant, I will try and do that. Thank you guys so much for being here. And yeah, Hari, logic gates is very simple. You just read it. There are no formulas in that. It's just like basic things. For example, let's say Hari and Hemant. Hari and Hemant both are, let's say, I'll just take Hari's example. Hari is very, very rich and very, very probably fast. If I say Hari is very rich and fast, that means if he is both, only then that statement is true. If he is only fast or if he is only rich, then that statement is not true. That's the meaning of the word and. Both of them should be true. If I use or, Hari is rich or fast, that means if is even one of them, the whole statement becomes true. That's what it is. Okay, Hari, fine. And if I say Hari is not rich, that means Hari is not rich. That's it. As simple as that. Okay, so there are three things which you should know: and, or, and not. That's it. Cool. Glad you guys have enjoyed this session. Please hit the like button, and I will see you tomorrow for the Sure Short series. And we are going to discuss 60 questions. And if you are interested in the crash course, please go ahead and join it right now. It's not for 10,000, it's for 4,000. I would, come on, do this for me, guys. For your master teachers, do this. Take the test series, attempt all the tests, learn from the discussions, use the doubt solving, because I cannot sit and solve all your doubts. Please understand that. We have a facility for you guys. Okay, and it is nominal charges, and all the test series, 20 mock tests are there. It has already started, but there are new batches also starting for, you know, the 4th attempt and all of that. So please enroll yourself right now, because if you join late, probably you are going to miss again few classes. Okay, that's it from my side tonight. Today afternoon. Hari and others, we are going to have a Sure Short series tomorrow. Thank you, Swati, so much. All right. And it's your birthday, Mandip, don't worry, you will probably celebrate it in a very good college next year. For sure, you will remember it. Okay, chalo. So, at the end, Vanakam Solunga, sir. Okay, Prasanna, Vanakam Solunga means, I'm guessing, I'm saying thank you. I'm telling that it is thank you, I guess. Alright. Okay, bye bye, Sanfia, bye bye, Sriniti. Great. God says thank you. Okay, and he also is showering some love on me. Excellent day. Bye bye. Hasta la vista. This was Shreyas here. Enjoy your Sunday and see you guys tomorrow.